Hello, everyone. Thank you for joining us today. My name is Taryn Blake. I'm the Community Engagement Program Manager for the Siemens software community. And we are here again today for another session of our Technomatics virtual user group. We have one of our community catalysts joining us as always, and we are here live for today's topic, which is custom heat mapping with free moving AGVs. Alex Dilg is one of our community catalysts, and for nearly 15 years, he's been a consultant at SimPlan AG, specializing in simulation projects, support, training, all using Technomatics plant simulation and other tools. His project focus includes intralogistics, covering both conveyor systems and vehicles, as well as library development for VDA and SimPlan. So the big 3 steps in today's demo and presentation are collecting marker and edge statistics for free moving AGVs, visualizing marker statistics with custom 3D graphics, visualizing edge statistics with default 3D graphics. And as always, we have our live Q&A at the end of the session. You are absolutely able to ask a question using your voice by raising your hand, which the button you should be able to see in the middle upper menu on your screen. When we get to the Q&A, feel free to raise your hand and one of us will take you off of mute so you can ask a question more easily. But of course, there's always the chat available to you as well. So that's my last bit of introduction before we get started. So Alex, feel free to share the screen.
Thank you. So today I want to show you something about one way of creating a heat map for free moving AGVs in plant simulation. I've uploaded a starting model. It's basically the same starting model that we used in the session 2 weeks ago, where I talked a little bit about collision control. So I'm not going to explain the whole model again because I did it in the last session. So I assume that you have seen it, or you could still watch it again if you're interested in the basic layout, but there's not really much behind it. So you see we have a layout with markers connected with connectors, and then I have 5 AGVs that are driving through the layout randomly. You can see the safety zones animated, and you can see that there is a distance control implemented. So that is one of the topics we talked about last time. So you can see if AGVs are getting too close to each other. I do not stop them completely. I let them drive with very slow speed until the other AGV is out of the way again, so that they are continuously moving throughout the layout. So the first thing we want to do is collect statistics for the markers. As you've probably already seen when you start working with these objects, there is no tab statistics provided for the markers. So we want to collect statistics now ourselves. So I will start by editing the marker class that I used in my model. And I will add user-defined attributes. We'll call this one total count. So there I will count how many AGVs go over a certain marker. So that will be integer, and then I will check the initial value box. I could put zeros in here, or just leave the field empty, then it automatically is set to 0 as the initial value. So the initial value ensures that every time I reset the simulation and I start it again, that my statistics always start at 0. So that's very important when you use or build your own statistics, to always ensure that you have a reset or init mechanism that works properly. So here I'm using the initial value. I would also create a second attribute. I call it stat average per hour. So there I will just show how many AGVs go through a marker on average per hour. So I'm going to use real for that, and again activate initial value. So I already have a method here, a marker arrival control that is assigned to all the markers in the layout. At the moment, this method is empty. Let me again make a little more space here so you can see the things a little better. I'll do it like the last time. I'll duplicate the model. So then here I have the starting model without any of this stuff. And then in this case, I think I'll just go to the complete model in the end. There doesn't make so much sense to have the steps in between. Okay, so my marker arrival control is empty at the moment. Like most of controls here, you have the anonymous identifiers at the character, so that references the AGV that is reaching a marker, and then the question mark that references the marker that is actually being reached. So I will use an explicit method for the marker statistics. So I will call it write marker statistics or set marker statistics or something like that. And then from my marker arrival control, I will call this other method and tell it which marker was reached. So in this other method, set marker statistics that I'm calling, I'm passing a parameter similar like last time. So I'm passing the marker. So I have to define that as a parameter. The add is still valid. So if you're not familiar with that, the add that references the movable unit that triggered the original control, that will stay valid throughout even other method calls. So I'm calling a different method now that will change what the question mark means. So in this case, the question mark will now be the method add marker, just in case you're not familiar with these things. So I have my marker attributes. So let me just copy them from the So I simply count my total count up by 1. And then I have my second attribute that was stat average per hour. And that will be my total count divided by the time that we have, that the simulation has run so far. You can get the time from the event controller by creating the sim time argument that gives you the total time that the simulation has been running. And if you divide this by 3,600 seconds, if you want, then basically this gives you a fractional number of hours that the simulation has been running. And then if I divide the total count by this, then this will set the this will give me the average number of AGVs that went through a marker per hour. Maybe we can do something like step 1. So now when we run the simulation a bit, I can now look at one of the markers, and then you can see here on the user-defined tab how it's counting up the total count, the time an AGV passes, and then also the average number of AGVs per hour, which is at the beginning a little high because I don't have so much time spent here yet. Also, we could use the rounding function to have this value not displaying large number of decimals. Okay, now it looks better. So you see now I have close to 800 AGVs that went through this marker, and I've spent a little more or 8.5 hours. So on average, that's 90 something AGVs that went through this marker here. It's one very simple statistic that I can collect here. And for the edges, I will do a similar thing or a similar approach, but I will collect also another maybe more interesting statistic. So I will do the same thing. So I will add statistic attributes for my connector. But because I didn't prepare well enough, I used the connector class here from the basic material flow folder. So this is the one that is being used in the model. In my normally in a project, I would not want to modify any of the objects that are in the basic objects folders, because I would not expect that they are different from the state in which they come with a clean installation. So that's why I would now move or duplicate this to the user objects folder to make it obvious for somebody else who opens the model that this is not some basic connector, but it's a special connector because, for example, I will have added these statistic attributes. So the first attributes will be the same as for the marker, stat average per hour is real, and again initial value. And here now I also then want to collect the time that the AGVs spend on a connector. They are not traveling on the connector, and they are also actually not really traveling or they're not really located on the markers as well. So actually the marker is more like marking a position, a coordinate in the layout that the AGV is traveling to, but it's not really located on the marker, and it's also not located on the connector. But if we build a layout like this, where we use the connectors to show the possible routes, I could still say if I'm going from this point to this point that I'm basically traveling along the connector 16. So I'll do a similar thing, start total time on connector. So just leave this away, because I mean we know that this is a connector. So start total time. So here we'll use data type time, and again remember to add initial value, and then stat average time. Okay, I just saw in the corner of my eye from the chat. Yeah, so this is the second session, but it's completely different topic. I'm just reusing the same basic model to show the heat map things. Okay. So I will now have a second method, call it connector statistics. And I will also call it from my marker arrival control. So first I've collected the marker statistics. Now I want to collect or set the connector statistics. So my problem now here is that that in my connector statistics method, basically now I'm passing along the marker from the arrival control. So that's basically where I'm leaving now. So that's how I consider the statistics. So I'm calling it from the arrival control to say, right now I'm at this marker. The AGV will be going somewhere else. And we have to now find out from where to where the AGV is going. So for that, I can ask the AGV to give me its intermediate route destination. But of course, my AGVs are driving through the layout. Once they have reached a certain destination, they will stop there for 5 seconds and then they drive on to a next random destination. So it may be that I arrive at the marker and then I call this connector statistics method, but I don't have a new destination yet. So before I query the route intermediate destination, I should make sure that I actually have a destination so that the AGV is not currently idle and waiting for a new driving order. So making sure that this is the case, then I can find out where it is driving to. In these kind of aisles, it's very simple because there's always only one marker connected to it. But in the areas here on the side, you can see there is like intersections, and then I can have two predecessors, two successors. So it's not clear. I have to find out where the AGV is going. I know the two markers, but I don't know which connector I'm using, right? So I know I'm going from here to here, but I don't know that I'm using connector 8 for this. So for this, in this model, I've prepared a connector matrix that simply says from which marker to which other marker, which connector can be used, or which connector is here in the model connecting these two markers. And the blank spaces show that these markers are not connected directly. So this is prepared here for this model because that's not the focus. I used this method here that you see in the class library, fill connector matrix, to fill this table. So feel free to look at that method or reuse it. Basically, we would just need a small loop here to find out which connectors there are from the starting marker and which is the connector that reaches that other marker that I'm going to. But to keep this a little simple, I can take this from my connector matrix. So this is the connector that is going from one to the other marker. So now I can use my same statistic attributes and update them. So my total count and my average per hour. Let's see first if this is working. Okay, so the average per hour and my total count, that is what I'm currently connecting already. So that seems to be working fine. But now what I want to have is how much time do I spend from one marker to the other? So how long is the travel time? Because you see that in areas where there is a lot of traffic, the AGVs slow down, or they have to wait for other AGVs. So there they will spend more time getting from one marker to the other than along these aisles where they can just travel more or less freely most of the time. So to get this additional statistic, I can at this point, so after I use the wait until, so anything that is happening before this line could be potential waiting times on the marker itself. So, but after this point, I'm leaving the marker. I may not already be moving, but the AGV should be leaving the marker. So maybe it has to rotate, accelerate, whatever. But anything before this is the AGV waiting for a new job. Anything after this is the AGV should start moving to that next marker. So first, I remember the time when I started traveling on that connector, and I save it in a local variable. And then here, wait until the AGV is at the destination marker. The problem is that this is just an intermediate destination marker because I'm telling the AGV, for example, to go from here all the way to here by setting this as the destination. So any markers that it's passing in between are determined automatically, but I don't really see them. So I cannot query destination was reached here because that will only wake up when I reach the final destination. So what I'm going to do is I'm adding a attribute to my AGV class, call it current marker. That is to object. And then in my marker arrival control here, I set this attribute to the marker that I've reached. And that now gives me the possibility to add in my connector statistics methods to say wait until current marker is next marker. So for any marker along the route to the final destination, I wake up here and I can now say connection step total time is increased by the time that I spent. So I get the current simulation time, and I subtract when I left or when I started driving along this connection. And then I have my my average time, which is simply, again, my total time divided by the total count, so the total number of AGVs that drove along this edge or on this connector. And that gives me my 4 statistics for the connector. Again, in here to see the. It's probably a little small, but I cannot make this larger. So I hope you can see it. So we have my total count 370, and in total all the AGVs that traveled along. So from this marker to this marker here, they spent like 47 minutes. So on average, that means they spent 7.5 seconds getting from here to here. And if you look at a different connector, maybe this one up here, then you will see a much smaller average time because, as I said, usually here along these aisles, I can just drive straight through. But here in these areas, there's more congestion or more traffic, so typically they would spend more time there. So, but because it's very cumbersome to open 100 connector dialogues and then look at the statistics, what we now want to do is use these custom statistics that we collected and show them in the layout. For the marker, I have a marker class that I used in the layout. I'll open this in 3D. And I will add a extra graphic group and call it heat map. Heat map. That's my special graphic group, and I will add for example, a cube in here. So that's a little big. So maybe 0.5 and 0.2. And for this cube, I will I activate the material? Yes. So I activate some material and make it a little transparent. So now after that, you can see that already in the layout, some of the markers are now displaying this new graphic group. Some of them are not. For the graphics, I don't have something like initial value. So I will add a reset method to the marker. I simply inherit the 3D graphics on reset. And I will also hide my graphic group heat map so that initially it's not visible. Let's open for a second. So now when I reset my model here, then everything looks clean. And then I'm ready to display to activate this group once I have some color code to show for the different markers. Okay, so I will now again put a new method here. I will call it from my set marker statistics method. You don't have to split this into different methods. I just think it's a good idea to put different functionality into separate methods. But of course, it's not so many lines of code. You could do all of this in the same method. So after updating my statistics, I will then draw the marker heat map. And in this method here, I want to look at the average number of HEVs per hour. So if my average number per hour is less than, I don't know, 80 HEVs, then I want to use a certain color. Else, if less than 130, I use a different color, and then I have a standard color if it's even more than 130. So if I have less than 80 AGVs, that's not a lot of traffic. So I want to make my marker green. When you're working with colors, I don't know if you already know this. If not, then here you will see there is a function called make RGB value. And if you use the autocomplete shortcut control space, then this will open the color dialog where you can now select the color. So for example, here I want to use green. And if it's more than 80 but less than 130, then I want to use something orange. And if it's more than 130, I'm using red. So this is a simple code to have 3 different colors, depending on how much traffic there is on the marker. If you have more or you want to have it more flexible, I would do this via a data table. So, and then after determining which color I want to use, I set this color as the material diffuse color of the first and only graphic in the graphic group heat map. So that's what this code here is doing. So it gets the 3D graphic group heat map, the first graphic object, which is the cube that I just created, and then it sets the material diffuse color, which is one of the 4 color attributes that you can set to my green, orange, or red color. And then it shows the graphic group heat map to make sure that I can actually see the green, orange, and red cube. So let's test this out quickly. So with this approach, every marker has to be passed 1 time before I can see its visualization in the layout. But of course, you could implement this differently. In this layout, it doesn't make that much of a difference because after a few minutes, every marker has been passed at least once. And you can see now that they have use these different colors. Whatever you use as the scale, of course, that depends on maybe you have a scale that you have to use, or else there's some flexibility. Of course, if I want to have a lot of green in my layout, then I would use other values than 80 and 130. But you can change this in the method. Okay, and then the last step, which is quicker and simpler, is to do the same thing with the connector statistics. That will not be a lot of code. Just take this method here, I copy it, call it draw connector heat map. Similarly, after I collected the statistics, I then call this other method. So here I don't want to look at how many AGVs passed on this connector on average. I want to look at the time instead. So I just change my my attribute that I'm looking at. And I wanted to use 2.5 seconds here for green, and then 4 seconds for orange, and anything longer than 4 seconds, that would be red. And for my connections, I don't need additional graphic groups or additional graphics. Here there's a simple way to just set the color attribute to paint the connector in different colors. But again, to make sure that when you reset the model, then you don't want to see connectors in the wrong colors that do not reflect the current heat map. So yeah, also I will put a reset method on my connector class to make sure that the color is always the basic color that I have here in my class. So if I change this to, I don't know, gray or whatever, then all the connectors are gray. Maybe rather black. So this is the last step. Now you can see again the same thing. Every connector has to be passed once before I update the color, but you could implement this differently. You could collect the statistics and then only once every hour go through all connectors and all markers and then update the color to make it more efficient. But even with this approach, I'm already took me already a little more than half an hour. So that's why I made it a little quick and dirty here. But yeah, you can see the different colors now in the layout of the connectors. So for the connectors, I simply use the built-in color attribute to make it easier with the implementation. And then for the markers, I added a color cube in a graphic group that I paint in different colors. And yeah, looking at the layout now, you can better with this. You can directly see, or you could use other colors or more or less colors, but you can quickly see in which areas you have a lot of red and orange. I mean, this is probably clear to everybody who looks at this layout that in these areas where you have the intersections, the AGVs turning around and taking shortcuts, that there is a lot of traffic and that they will spend longer time there. But of course, in a more complex layout, this may not be so straightforward. Yeah, right. So I think that's everything from my side. What I wanted to show you, collecting some statistics for the markers, collecting statistics between markers, utilizing the connectors in plant simulation, and then painting this with colors in the layout to quickly visualize what areas are green, what areas are red. So where do we maybe have to take a closer look and add additional routes or add additional maybe parking positions in between or whatever options you have to improve the layout. Yeah, good. So that's it from my side. So now we can see if you have any questions or issues. I think I didn't see anything in the chat yet.
Oh, we do have a hand raised. So Benedict, you are now able to use your microphone.
All right. Yeah, thank you, Alexander, for your presentation. It was very nice. I have a question regarding the arrival control of the markers, because I didn't try that in that use case so far, but I tried to use the markers. And I had the problem that sometimes the arrival control is called 2 times by arrival. And that would that leads to problems. Do you know the reason for that and how to fix that?
I mean, I don't really know the reason. I think you also had this in the discussion in the forum that you opened a couple of weeks before. I myself also have reported, I think, 2 cases where I stumbled upon this. I don't know the reason because I'm not one of the developers. I do understand that this can be quite tricky because of calculating when they reach a certain location, and then when something's changed, it is reevaluated. So it looks like it arrives there again. I mean, the simple workaround is if we have exactly like this. If this was already set, then I can just skip this method, right? So it's So this should not happen. I know that it comes up in special situations or layouts again from time to time. Yeah, that's basically what I'm doing. So I'm always ensuring that I have this in my method to, if this should come up because one of the markers has a minute range coordinate, so the inner calculations go wrong and it assumes that it has to call it again. Yeah, I just use something like this. It's similar also when I have entrance controls on other objects, exit controls. I may also do something like this to make sure that I myself know, is this the first call, the second call, or whatever. Yeah, so something like this should catch it. If you have it in your layout, of course, I think as they posted on the forum, if in any way possible, it would be good if you report it to support so that they can have a look and hopefully fix this situation. But in most cases, they would need the actual model because it's hard to tell from general point.
Yeah, understand. Thanks for that. Actually, I have a second question, if I may. So we use the use the attribute current marker, right, to determine where the AGV is currently.
Yeah.
And we trigger that, or we set that attribute with the arrival control of the markers.
Mm-hmm.
Here I have the question: is there another way? Because when the AGV is driving and we hover with our mouse over the AGV, we can see the route and we can see where it's currently at. However, so you can see the black arrow at the left, right? So the program already does know where it is. However, I didn't find any place where I can grab that information.
Yeah, I mean, for this one here, this is the get route intermediate destination. In this case, it's right, X4 Y2. That should be where the black marker is. So X5 Y2 is where it started driving, which is just the orange one on the right in this case. So X4 Y2, the get route intermediate destination, is the next marker that it will pass. So that's where the black arrow is pointed. Of course, there are many different ways of how you make AGVs drive around in your model. So this is right for this case where I use the destination and I have my markers connected with connectors. If you use something like set route, it may be a different case, or set route segments or drive actions. There are many different ways of how you can make them drive. But for this scenario, this would be the answer. The destination is the final destination, so X2 Y4. And the get route intermediate destination is the one with the black arrow. But I cannot, without my additional attribute, wait until I have reached that marker with where the black arrow is pointing at. I need an additional attribute.
Okay. Yeah. Okay. Yes. Thank you for that. I'm just noticing that I asked the wrong question because the thing is I forgot that I know where I can find that information. However, I cannot find the information where, in which position of the route I am right now. So right now we would be in position 2 because the arrow is at the second position. Is that anyhow possible to find the number?
You have the get route method, which returns the array of. So this is what it's displaying here, right? The six markers, and then of course you could use get route dot I think find for the array, and then find the get route intermediate destination, provided this marker is not twice part of the route, because he has to go some kind of circle, which I think will not happen if. I mean, yeah, it could happen if you have if you set the route explicitly yourself, then of course you could include a marker 2 times. But I think if you work with destination, it should normally not happen. Yeah, if that can happen, then probably you will have to again have additional attributes where you kind of log where you've already been. So you say it's the first, second, third marker of my total route. But in the basic case, this should work, that you use get route intermediate destination, and then you ask this array that get route returns, which position in the array is that, the second, third one.
Okay. I just thought like the find method is more expensive than just like reading an integer or something. I thought maybe there is a different way to get the position of the arrow, but okay, thank you.
I think for this setup, I think not. If you use a destination, not a single destination, but a table with like a destination list, then I think you would have the destination list method that you could ask. But then again, you would have to explicitly give all the markers as part of the destination list. So then maybe that will become more expensive again. So, yeah. But this is one of the quite complex topics, right? So you have so many different ways of having them drive. So I think there's no generic answer, because this will look differently when you use other methods of having them drive. But
all right, thank you.
Yeah, you're welcome.
Perfect, thank you. Can you hear me?
Yes.
Yes.
Nice. Thank you, Alexander. Very nice topic. Very interesting. I just have one question. What I usually do for this kind of processes is, maybe it's wrong, but I use a worker class and just change the 3D or the 2D. And in this way, I can easily use the Sankey diagram. And yeah, I can set all the free moving, or using the footpaths and using the load and unloads. I just want to know what's the disadvantage of using this method instead of using the real AGV as you are doing right now.
That is a common option or alternative for modeling AGVs. Because you can then also use this broker mechanism, which has advantages. I would say if you have the Sankey chart shows you how much traffic there was between 2 points, but it will not show you like, was there congestion, or did it take longer for these 2 meters in the layout than for another 2 meters. You don't have, for the workers, you don't have acceleration. So that if that is relevant, right, for the AGVs, you can consider acceleration processes. If you say for the simulation, it's perfectly fine to have like a constant speed, then again, you're fine with using the workers as AGVs. That should not be a problem. You don't have any sort of collision control when you have workers. So the workers have the advantage, they have automatic obstacle detection. So they will walk around stations and walls and so on. But they don't care about each other. So one worker is not like waiting for another worker to pass or something like that. So if that is part of the focus of your simulation study, to say, I have, for example, here in this layout, I know I have these areas here where there's a lot of turning around, and all the AGVs that come from one of these aisles, they have to go through these points, and then they interfere with each other. Is that a problem, or is that fine? I think that will be more complex, or more effort to do that with workers. With the AGVs, you have more flexibility. Also, when they leave a marker, you have the distance, the safety zones. Yeah, I think it's definitely not wrong. It's a common suggestion that we also make, especially when you like have to do a quick analysis. Yeah, you can make some assumptions. Like I said, you don't need acceleration, for example. You don't want to learn, or don't have time to learn how this new topic, how to control AGVs, but you know how to work with workers, then that's a fine solution. Yeah, I would say the major difference is that with the AGVs, you can have interference with each other. So like blocking or waiting because another one is in the way, and then evaluating how much time does that cost you and where do you have problematic areas in the layout. I think it will be a little different or difficult with the workers. I mean, you can have capacity on the workplaces, but that's not, I mean, anything between the workplaces, again, there can be as many workers on the footpath or walking freely as you want. So there's not really a collision kind of thing between workers. I would say that's the biggest difference.
Correct. Okay.
Okay. Again, the Sankey chart only shows you, or would in this case would only show you basically what I'm collecting with my total count. So it would tell you along this line 30 HVs went, and then along this line 50. So then one of the lines would be thicker, but it will not tell you anything about how much time they spent in a certain area of the layout. So this kind of congestion, traffic jam situation, which is often relevant or focus of simulation studies with AGVs, this will not come out of the Sankey chart, unless that will be another feature extension.
Yeah. Okay. Yeah. Thank you so much, Alexander.
Good. Yeah. Welcome. There was a question by Jesse. How can you make colors relative to the max and min across all markers? Yeah, that was actually what I wanted to do first. So like have a scale of, like, say you have like the highest value of average time that I have anywhere in the model is whatever 10 seconds, and then I would say, okay, if you spend 9 seconds, that's like 90%, and based on that have my colors not with absolute numbers but with like a percentage of the max value. To do this, basically, you would have to, at one point, collect the maximum and maybe also the minimum value. Of course, you could put this in simply in a variable here in the layout. So every time I update my average time or my total count or whatever. So this is locally for each single object, and then you could have like one global variable object where you collect the max and min average time of all the connectors in the layout, and then you could use this to have the relative to put this value into perspective of the max value, and then say if I'm above 80%, right? So that's probably what you meant. And if I'm above 80%, then I'm red, and if I'm less than 50%, I'm green, or something like this. Yeah. I think that would be the easiest way to just put one variable in the layout for that. Of course, that's also what I wanted to do first, but I skipped it because I saw that I'm already spending more than half an hour with this quick and dirty approach. Normally, I would have one data table here where I collect all the statistics for the connector. So I would probably not collect them as user-defined attributes. And then you have the table, you can just do max and min on the whole table. That would, of course, make it easier. So instead of a variable, you could have a table for the whole statistics. That would be the other approach. Sorry, it was a two-part question. I have connections that connect marker A to B and B to A. This would show overlapping. Yeah, I actually have this as well in this layout. Move these away so you can see here, for example, in this place, right? You have the two overlapping. Actually, I'm not sure whether this is still possible, but if I do a marker, yeah, you can have a. This is already connected, so I have to connect it somewhere else. You can use. I'm not sure how this is called, but like anchor points for a connector. So you could do it not like a straight line, but show it like this. This will have no. So this is actually a good question, because this will not this will not make the AGV drive along this connector, so drive like a curve, right? So you have to remember that the connector is only saying that from this marker to this marker there is a connection. The AGV will always take like the direct shortest path, maybe considering its curve radius, but it will not follow the shape or something of the connector. But yeah, you could use something like this. So when you create the connector, you first click here and then you press the control key to add anchor points before connecting. Yeah, it already exists. Yeah. Then you can move them around. I'm not sure whether I can still add them for an existing connector, but that's what you could do if you say this is overlapping and it's not good or clear to see. Yeah.
We got a thumbs up, so that seems like that was a good answer. We've got 2 minutes left, so if you think of something else, sneak it in the chat while I show the slide for our next sessions. Because I do, in case there's anyone new who hasn't been on these calls before, want to call your attention to this slide that's on the screen now. There's a URL that you can click on. It's showing a screenshot of the plant simulation virtual user group area in the Siemens software forums. So this is just for these tutorials. The only thing we post there are the videos to the tutorials, registration invites to the next sessions, and it's a place where we post the recordings as mentioned, and you can go in there, you can @mention Alex, you can @mention Stefan, whoever session it is, and ask questions about what you saw. So if you think of a question later, it's a good place to go in and ask about the tutorial that was given. You can share code snippets, everything like that in our forums. The image is showing you that we suggest that you follow the topic by clicking the follow button there. And there's a second button where you would want to select that you receive email notifications for every post. And that's just because it's a very narrow discussion. It's only exactly what you're hearing here. This topic's for plant simulation and technomatics. So the next 2 sessions are up as well. So next 2 weeks from now, Stefan will be back presenting on dynamic model creation. And he has another Python session scheduled for April 9th on accessing plant simulation in web applications using Python. So this AGV series has been really great, Alex. Definitely appreciate you jumping in to do this. Y'all, we really appreciate our community catalysts for Technomatics. Y'all have been just such a big help to the community spending this time to present these. So I do see a big thank you and then question going out to Gnome for function proposal. So anything else, Alex, you want to think as we wrap up in this last minute or so?
Well, on the off chance that one of the participants is here from Germany, I'll be at the Logimat fair tomorrow. So if anybody is there too, then you can come to the Simplan booth and meet me there. But
awesome.
I think nothing else.
Yeah, take a picture and post it in the forums. Let's see, there is a comment from Vladimir. I guess a suggestion around another method, but he's complimenting your connector use there. So seems pretty cool. And as you see on screen, I've got Alex's profile up for the community if you want to mention him there. And as a reminder, this video will be posted in the forums on Friday. So Friday of this week. So you can ask questions there. And I'm sure Alex will post the model again on this one as well. So sounds good. It seems like all the answers, quite the discussions going on in the Q&A over there in the chat. So if that's it, then we'll see everyone in 2 weeks.
Right.
Okay.
Thanks everybody for coming. And then see you next time.
Bye everyone.